Hey, it's Max again. I'm going to be trying to illustrate how to use the very popular serialization framework from Google called Protobufs, longer name being protocol buffers. If you've used JSON before or XML before, Protobuf is just one other type of text format for representing how data, whether numbers or text or what have you, should be compressed or made into a standard representation that anyone who has a definition for what that data should look like can reference the protocol buffer schema of a payload and be able to either what's called serialize or deserialize the protobuf data. First things first is we're going to get a hold of the Protobuf compiler tool. That's something that if you go to the official GitHub page for Protobufs and click on their latest releases. I'm on a Macintosh, so I'm going to scroll down to the OS 10 download, which is a zip file. I've already unzipped it, so we'll be able to go to Protobuf, and in the bin directory is our compiler for Protobufs. We can run it, and you can see there's some output about how to use the command. Basically, you just invoke the command, some options, and then you point it at where your protobuf definition files are. These are file names that are blah blah.proto. And these options are the most important part because we are instructing protobuf compiler command line tool what type of output we want. So an example would be with Java, which is what we're going to do. It will output an auto-generated Java class corresponding to each of the protobufs that we have defined. So I'll show you them in a second, but first let's copy this protobuf tool into our command line path so that we can invoke it from anywhere. And let's make a scratch directory called protobuf test. Let's cd into protobuf test. And what we'll do here is we will make a person.proto. And we'll give a few fields. Required will be a string, a name, and it'll be our first field. And then everything after that will be optional. Let's call it int64 age. Now these numbers at the end, I'm not going to give a breakdown of how you define protobufs, but the most important thing here is just that these numbers after the equal sign are unique numbers and are used by programs that are serializing or deserializing a protobuf to determine unique fields and where they are in the payload. So now that we have our proto-c command on our command line, we can point it with one flag, Java out, and we'll say Java out to our current directory, and we want to point it at person.proto. So you can see there's a warning because we're missing some header about specifying the version of proto that we wanted. You can see that we now have two files, our proto definition file and the auto-generated Java file. So we'll take a look real quick at the contents of the file, but you can see that it's a final class, it's a plain old Java object, and I'll show momentarily how we might use it effectively. I would most use it effectively in an IntelliJ project. So let's create a new one, a Gradle Java project, and we'll call it Protobuf example. You don't want to have to be dropping into your terminal to invoke Proto-C. I'm going to illustrate for you how to use a Gradle plugin to detect your proto definition files, your person.proto, for example, convert that to a Java class, and make it available to your Java code to be able to use the Java class representing your proto. So first things first is to look up the Gradle Protobuf plugin. The other thing we will need to do is find the Java Protobuf dependency. So here's the declaration for including the Java Protobuf library. But secondarily is the Gradle plugin that I want to illustrate. So it should be as easy as adding this plugin com.google.protobuf to our plugins list in our Gradle file. Now I've done that, let's refresh our Gradle settings. And what this is doing is it's downloading both the plugin for Protobuf for Gradle as well as the Protobuf Java jars. So that we should see them in the external libraries now. Yep, we got that there. So one thing we have not done yet is we haven't configured anything about the Protobuf plugin, but what we'll do now is we'll add our Protobuf, we'll add a new directory, let's say, and we'll call it Protos. And in this we will relocate our person.proto file. So we'll just copy paste the contents of that into this new file in the Protos directory. Now there's some plugins you can install, which I'd suggest you do for IntelliJ to handle proto files. We are not going to restart IntelliJ yet because those plugins are not very important for our use case. But having created this proto in the Protos directory, you'll notice that if we go over to the side tray for Gradle and we expand to see what tasks are available to us, what we now have is a generate proto task. So let's give a double click on that, and you can see that it is performing some subtasks, and you'll see that generate proto says there are no sources. So by default, what directory in your project root, and it'll also try to locate your protos using some defaults, which clearly those defaults haven't picked up ours. So what we'll want to do is for our source sets, you see that by default it looks in the proto directory. We probably need to rename this, so let's do that real quick. Let's call it proto and not protos. And let's try one more time running the generate proto task. You can see now it doesn't say no source. And if we look in our build directory, there's a new directory called generated, which if we scroll down, there's now a person outer class.java. So this outputted the exact same auto-generated Java class as when we ran protoc from our command line. So it's great that it's in the build directory. However, if we want to use it in our code, what we'll need to do is we'll need to auto-generate that person proto class to our source set rather than into the build directory. So where the proto definition is here, we want to output a Java class here. In order to do that, we need to take a look real quick at the different configuration settings for the Protobuf Gradle plugin. If you scroll down, this is a really well documented project. Here we go, generated files directory. There's probably more. Here we go. Change where files are generated. I'll include a link to this section in the show notes. By default, generated Java files are under a specific build directory in the top level directory of our project, which is what we saw in Eclipse. This is our build directory. Instead, we can add a block in our build.gradle, which indicates that we actually want our outputted Java classes to be in our project's source set. So we need to add a new section in our build.gradle, and we need to specify the directory we want it to go into. So in our case, we don't need it generated, I don't think. So let's reload our configuration for build.gradle. Let's try running generate proto, and you can see now we have our person outer class. So real quick, last thing we'll do is we'll create a hello world main class, and I'm just going to illustrate how we can make use of this person outer class. So person outer class, In fact, what we can do is we can reference person, and you can see that IntelliJ picks up the person definition, and we want to create a new builder. And what we want to do is we can set the name, and remember we had a second field, age, and then we can call build, and now we have a person, a representation of a person. And there's a default string representation of a proto, and that's all that we'll do. So we're going to create a person, and we're going to print that person out to the standard out. So let's run this. Sweet, printed out our the proto representation of our person. Now the second thing and last thing I'll show is how to read a person from a representation, a protobuf representation of our entity. So similarly, instead of calling new builder and creating a new person, we're going to use the method parse from, and given a byte string representation, we're going to create a person2. And similarly, we'll just verify that person2 is the exact same as person1. Now you'll see there's a warning about us not handling an exception. If we mouse over, let's add a try catch. We don't really care very much about handling that. And let's give this one last run. So yeah, you can see here's the first representation of person from line 6. Here's the second representation from line 14. This isn't a very interesting example. You might want to experiment with storing protobufs into a database like MySQL or Redis. You might want to verify handling data that might be transmitted over the network. For that, we'll check out in a later video gRPC, the popular framework for using protobufs as your protocol for serializing data between clients and servers. But I hope this illustrates some of the basics for you of using the Proto-C command line tool, as well as using the Protobuf Gradle plugin. Hope that was helpful. If you got any questions, leave them in the comments. Like, subscribe. I'll be back.